Hi AdMath students, we're going to have a look at some examples from the vectors chapter, chapter 8, and I'm going to start with number 2 from exercise 8.2. Now they tell us here that we have a triangle ABC, okay, and they told us that vector AB is A and vector BC is B. So let's draw that quickly and see what we've got, okay. So here is triangle A, B, and C, and vector AB is A and vector BC is B. So remember, being vectors, that means that AB must run that direction because it's AB, and BC must run that direction because it's BC. Okay, and then they ask us that they want state in terms of the vectors A and B what vector AC is and what vector CA is. All right, well, AC runs from A to C. Okay, so that goes from here to here. Okay, now how can I move from that way along vectors that I already know? Well, I could go along AB, which is the vector A, and that means I could then go along B to C, and I'd get from A to C. So the vector AC must be represented by A plus B, because that's just going in the direction of the A vector and the B vector. And then, of course, they ask for the CA, which is the opposite direction of AC. Well, that just means it's the negative of the A plus B. Okay, so remember that both of those must be negative, so we could also write that as negative A, negative B. Does that make sense? I'll just move that up so you can see the last little bit there. There we go. All right, so that's the answer then to question number 2. Okay, I'm just going to also clear away here. Let's just clear this and we'll do the next question. Right, so I'm going to leave question 3 because that's just drawing some vectors, and you should be able to follow that quite carefully. If they give you the vectors A, B, C, then you can measure those and you can draw some resultants of the other vectors that they ask, like A plus 2B, etc., etc. But I'm going to have a look at number 4, okay? Now, number 4 says that if the magnitude of A is equal to the magnitude of B, in other words, the sizes of the vectors are equal, but the vectors themselves, A does not equal B, in other words, their direction could be different. Explain why A plus B bisects the angle between A and B and is also perpendicular to A minus B. All right, now for you to do this one again, you're going to have to go and draw, and generally all the vector questions we do will be drawing questions. So let's firstly draw a vector A, and then we'll draw a vector B. Okay, now A plus B would be the vector that goes here. Okay, from that start to that finish. But notice that I could also draw a vector B here, and I could draw a vector A there. These are the same vectors, but what shape do these end up then making? Remember that the A size was the same as the B size, okay, and that this red vector is now represented by A plus B. Okay, now that shape then, because remember these vectors now are parallel here, so I've got another B here and I've got another A here, they make what we call a rhombus. And what do we know about the diagonals of a rhombus? Well, we know that the diagonals of a rhombus bisect the angle. So there's the reason that the A plus B vector bisects the angle that is made between A and B. Okay, because here we can see this is an angle between A and B, and it is bisecting. Each part of those angles are equal. Now, what would the vector A minus B look like? Okay, well, A minus B would be the vector that starts at this point over here and goes minus B plus A. So in other words, from that point to this point, in other words, the vector A minus B is this vector. And it is the other diagonal of the rhombus. Now, what do we know about two diagonals of rhombuses? Okay, the two diagonals of the rhombus bisect each other at 90 degrees. So that is a 90-degree angle. That's a property of geometry that you should be familiar with. Okay, and so therefore we've answered the question number 4 now. Okay, if you go back and have a look at what they said there, they said show or explain why A plus B bisects the angle. Well, we've shown that on the diagram because of the rhombus, and why A minus B is perpendicular. Okay, and is A minus B is the, sorry, A plus B is perpendicular to A minus B. Okay, and there we have it. Okay, so then let's have a look at question number 5. Okay, so I'm going to clear this one away. Now, number 5 says that in triangle OAB, we've got another triangle. And remember, we've got an OAB triangle. So just in terms of O's, we start at an origin, you see. So O, A, and we'll make B over here. There's triangle OAB. Okay, and we've got a vector OA, we've got a vector OB over there. Let's have a look and see what else they ask. They said in triangle OAB, the vector OA is called A and the vector OB is called B. So let's label them. Okay, so that's A and that is B. Then they say that M is the midpoint of AB. So we have a midpoint over here, an M. Okay, now they ask us, state in terms of A and B, what is the vector AB, AM, and OM? Okay, so we want the vector AB, and then also AM, and then also OM. Well, how do I get from A to B along vectors that I know again? Well, I could go from A, I could go this way because I know that vector. So that would be negative A because I'm going backwards on that vector. But then I'm going forwards to B here. So negative A plus B, or simply B minus A. Are you happy that AB is the vector B minus A? Because it goes from A, negative down to O, minus A, plus B. And minus A plus B is the same as B minus A. Now, what did they tell us about M? They said that M is a midpoint, which means that if I go from A to B, and that is the vector B minus A, then from A to M is going only half that distance, and it's in the same direction, so it's the same vector, so it must be half of B minus A. Okay? So now I know that that AM vector there is a half B minus A. And now they ask us to work out what the OM vector is. That means going from O all the way to M. What is this blue vector now? Well, again, I'm going to need a path that I know already. Okay, so starting at O, I could go along A because I know A, but I could go along this part here, which is half B minus A. So therefore, we could add those two together. We could say A plus a half B, and we can multiply that half into the bracket and get minus a half A. But what is A minus a half A? Well, that's simply a half A. So the answer is that the OM vector is a half A plus B, or a half A plus a half B, which you could factorize the half out and write it as a half A plus B with some of your algebra. So there we go. There's the OM vector. Now, just to make a point at this place, okay, or this juncture, it's an important aspect of vectors that you follow paths along paths you know, and then work out new vectors from those paths by adding the vectors up. Remember, the principle of vector addition is that you can simply follow one path that you know and then say that one vector is given by the sum of the other vectors that you followed along the paths that you already were given. So if you can do this question and understand it well, you're going to set yourself up beautifully for the rest of the questions that follow. Okay. So let's have a look now. So that was question number 5. Okay. Now, I'm also just going to do question number 6, and then I'm going to leave number 7, 8, 9, and 10 for you to have a look at. Okay. So this one, we have a triangle called OPQ. We'll draw it very similar to the last one. O, there's P, make O over here. There's Q. Right, so there's our vectors, and this is a triangle. Okay, and let's make PQ another vector. Now, they draw this triangle. What do they say about this triangle? Well, they tell us that the OP vector is P and the OQ vector is Q. So we'll fill those in. OP is P and OQ is Q. All right. Nothing too difficult about that. Then they tell us that R is the midpoint of OP. So we have a point R somewhere over here. There's R, okay? Midpoint of the vector OP. Then they also tell us that S is on the line OQ, okay? It lies on OQ, but it is so that OS is 3SQ. In other words, S must be somewhere here, because the OS, this line, up to S, is 3 times as long as the line from S to Q. So this is 3 units, that's 1 unit, okay? We don't know if it is 3 and 1, it might be 6 and 2, or 9 and 3, we don't know, but we just know that the ratio of those is 3 to 1, okay? So that's what they've given us, all right? Then they ask us to find a series of vectors. Now the first vector that they ask us to find is OR. I'm going to list all of them. It's OR, PQ, OS, and RS. So OR, PQ, OS, and RS. All right, so the OR vector. Well, we know that the OP vector was P, okay? But OR goes halfway, so that's easy enough. We can write that OR is a half P. Secondly, the PQ vector going from P to Q means I'll start at P. The only way I can do that is go backwards along here to O. That would be minus P. And then positive direction back on Q. So I could write that this one is Q minus P. There's the PQ vector that goes from P to Q. Now the OS vector, okay, goes all the way along the OQ vector, but doesn't get all the way. And we know that the OQ vector is Q, okay, but OS only goes 3/4 of the way. So OS must be 3/4 of Q, okay. And lastly, they want us to find a vector RS, okay. Now R, we have this point over here, and S is that point over there. Okay, so we know we want to now find this vector. This is the more complicated one to find. I'm actually going to mark it in blue here. Okay, so RS, how do I get from R to S? Well, one of the ways I can do is firstly come down here, and we knew that that vector, because OP we were given, okay, or OR we found was a half P, but going backwards along there would be minus a half P. And then I'm going forward over here, and that was 3/4 Q. So there is the RS vector in terms of vectors that I already know. Or you could write that as 3/4 Q minus a half P. Well, I hope that makes sense. That should give you enough information to try and do all the way up to number 10 in that first section. Okay, we're going to move a little forward. I'm going to go now. We've done position vectors as well. I've discussed that in class. So let's go and look at exercises from 8.3 now. All right, so here we go. So let's see what they've given us here. Exercise 8.3, number 1. Okay, they told us that the vector P is 3a minus b. Let's write that out. So P equals 3a minus b. They also told us that the vector Q is 2a minus 3b. So those are the components of each of those vectors, okay? They want us to find the numbers x and y such that x times the vector P plus y times the vector Q is equal to a plus 9b, okay? So x times the vector P plus y times the vector Q must be equal to a plus 9b. All right, well, what would x times the vector P be? Well, that would be 3ax minus bx. I'm just multiplying the x to the vector 3a minus b. And what would the y be? Okay, well, that would be times the q would be 2ya, okay, or ay if you want, minus 3yb. Okay, that would be q times the y value. All right, now which parts have a in them? Okay, well, we can see that one has an a and that one has an a. So let's factorize that a out. That would give us a, and that would be 3x plus 2y. And then which parts have b in them? Well, we've got this one with the minus bx and the minus 3yb. So I'll say let's take out minus b here. Okay, and what do we have left then? X plus 3y. Okay, or if you want it, we can keep it as plus b if you wanted to, and then we'll just have to make both of these minus. But that's sometimes a bit weird, but not the end of the world. We can do that, okay? So we can have two minuses in a bracket like that. But I think the taking out of the minus is a little bit easier, okay? So either one of those two ways would work. Right, I'm going to move this up a little bit. We're going to keep going. Remember, we've now got to find values for x and y. Okay, that will give us that vector on the right-hand side, the a plus 9b vector. Well, clearly, because we've got the b's and the a's separated now, we can write that the 3x plus the 2y must be the value that is in front of a, which happens to be a 1. Okay, so that must be equal to 1. And the minus x minus 3y, well, that must be equal to, because we've got a plus here, so plus what b? Well, it's this thing must then be equal to the 9, okay, because that must make the 9b. So we'll make that equal to 9. You see, we're just looking at what we have on the one side of the equation and replacing the things that we have that are different with the things that are similar on the other side or the same. So now we end up with two simultaneous equations. And now you've solved simultaneous equations before. It's not the nicest of simultaneous equations because none of them are equal, but we can still solve these. Okay, so the thing is we'll have to get something to be equal. And I think multiplying the bottom one by 3 would be the most sensible thing to do, because then we'll get a minus 3x. Okay, so let's multiply the whole of the bottom equation, by 3. Then we've got, okay, minus 3x minus 9y is equal to 27. Now I can take this equation, which is over here, and I can add it to this equation, okay, over here. Remember, I told you to label equations. We can do that. So we can say 1 plus 2. Equation 1 plus equation 2. Well, what is 3x plus the negative of 3x? It's just 0, so that disappears. And 2y plus the negative of 9y is minus 7y. Okay, minus 7y. Okay, but what is 1 plus 27? It is 28. Okay, well, that gives me a nice value for y. Y turns out to be minus 4. And if I go back and I put that y in, okay, 3x plus 2 times minus 4, in the top equation there, number 1 again, that's 3x minus 8 must equal 1. Okay, well, if 3x minus 8 must equal 1, it means that 3x must equal 9, and therefore I get an answer for my x there to be 3. Right, so if x now equals 3, I can go back to my original equation story, and we can now go and say, okay, that the values here must be 3p and minus 4q would equal a plus 9b. Now I'm actually going to prove this to you. Let's see if that is actually correct. Okay, so if I said 3 times p, it would be 3 times the 3a minus b. Okay, so 3 times 3a minus b is 9a minus 3b. And minus 4 times the q vector would be minus 8a and plus 12b. Now when I add those two vectors together, okay, and that's what we did over here, then we say 9a minus the 8a gives you a, and minus 3b plus the 12b gives you 9b, and exactly that is what we got. So you can see that those x values and y values must be correct for those values, because they give us the vector of the a plus 9b that we were given originally. Alright, so a fairly long question to go and reason out, lots of work, but yes, that's what ADMATS is about sometimes. Okay, it does take a little bit of work. Alright, so you should be able to do number 2 if you can do that, if you can follow through that number 1. In fact, most of these you should be able to do quite easily. Okay, I will pick another one to do, and I'm going to pick number 6 here. Let's have a look what this is. Okay, so they tell us that there are position vectors of p, q, and r. Alright, so remember that a position vector is just one that starts an origin. So we could have p we could have Q, and we could even have R going down here. Okay, there are 3 vectors. Okay, all of them start at O. Okay, and this would be P, Q, and R if I went to OP and OQ and OR as points. Okay, so the position vectors of P, Q, and R are given as A minus 2B, 2B minus 2B, and then minus 4A plus KB. Okay, so let's have a look at these. So we've got A minus 2B, then 2B. So this vector here is A minus 2B. This vector is just 2B, and the other vector was minus 4A plus KB. So minus 4A plus KB. So now they've given these vectors in terms of A and B vectors, okay? Whatever A and B are. Again, we don't know, but we don't need to. We'll work out what they want from this. Now, they've said that, okay, if the P, the Q, and the R are collinear, so in other words, the way I've drawn them is not what they are, okay, because they're all on the same line, okay, then we must find the value of K and also find the ratio of PQ to QR. All right, well, let's first say, okay, what they did tell us is actually the way I drew these originally was actually not correct at all, okay, but that doesn't matter, okay. But these vectors are actually collinear. In other words, okay, the A minus 2B vector and the 2B vector, okay, they must all lie on the same line. Okay, they must all lie on the same line. Okay, so in other words, let me write this, let me draw this a bit down here for you. So A minus 2B and plus the 2B vector. Okay, if I added those two up, I would get P plus Q. They are on the same line, so they must be parallel, so their direction can't be different, okay? And their direction can't be different to the minus 4A plus KB vector, okay? The minus 4A plus KB vector. So let's put that one here. And if I said Q to R, okay, so that would be 2B plus that vector, which is the minus 4A plus K, sorry, that's KB over there, okay. So what must I say about these two vectors? Well, what I must say is that if I went from P plus Q, then that's the same as going from Q to R, because they're on the same line. They must have the same direction. They must actually be the same vectors, okay. Let's have a look here quickly. Let's go back. Okay, so position vectors PQ and QR are given by that. Okay, now if P, Q, and R are all collinear, they all sit on the same line, they must be scalar multiples of each other. Okay, and then they also want to know what is the ratio of PQ to QR. Okay, so we'll have to work out the PQ and QR vectors. Okay, so PQ vector, okay, if I went from P to Q, I would simply add them up and go A minus 2B plus 2B, which would give me A. And then Q to R would be minus 4A plus KB, okay. All right, so let's put that in quickly. Right, so A minus 2B plus 2B gives me actually just A. Right, but that must be the same here as 2B minus 4A plus KB. Now, of course, if I've only got an A vector here and there's no B, in other words, 0B, okay, then this must also be 0B. So what value for K will make this 0B? Okay, well, the answer is that it's minus 2, okay? Sorry, let's move that up there. Right, so like I say, this KB will have to be a minus 2 to cancel this out, because I've got to get a vector that lies in the same direction. They're collinear. And if there's only an A component from the P to R vector, then from the P to Q vector, then from the Q to R vector must also only be an A component. Okay, and so what I'm going to do is I'm going to make k equal to -2. There's my k value. And that will mean that I end up with the q to r vector being simply minus 4a. Well, we can see that the one runs in the opposite direction, but that doesn't matter. Along a line, we can go in two directions. We can go positive or we can go negative. We're still on the same line. Okay, and we can see that the ratio of the size of the QR vector is 4 times bigger than the P to Q vector, okay, which has a 1a in front of it, or a 1. Okay, so going to the second part of the question, which is the ratio PQ to QR, the ratio is 1 to 4. Okay, now it doesn't matter that it's 1 to -4. Remember, the size is what the ratio is about, and the vector can't have a negative size. It's still a length of 4, even if it's going in the opposite direction. So there we go. There is my ratio of 1 to 4 for this vector. All right, now that again leaves you with a series of questions to answer. Okay, so this chapter, or exercise 8.3, okay, has quite a few ratio related questions and finding a scalar multiple questions. You can see it goes right up to 24. Okay, 24. So I'd suggest that you pick a few here. I might do a couple more in class for us, okay, but then I'm going to carry on in the next section. We did do components of vectors as well, and so we did get to actually do 8.4 already, but I will do some of these exercises in the next video. Okay, so we're also going to talk about something called unit vectors in a moment. We'll do that tomorrow in class, and then we'll go on to 8.4. Okay, good. Well, that gets you at least some of these questions going, and you can try those as part of your homework.